Example 4 is working with the Pythagorean identity. So we want to solve the equation -2 cosine squared x plus 1. What we should see is that we have both a square and a first power, but they're different trig functions. That's going to cause us problems until we realize cosine squared, we know how to write that in terms of sine. In fact, we know that sine squared plus cosine squared is 1. Rearrange that, we get that cosine squared of x equals 1 minus sine squared of x. We're going to plug this in to get -2 times 1 minus sine squared x plus 1 equals sine of x. Now we have an equation that just has sine in it. That's easier for us to work with. So we distribute this -2. We get -2 plus 2 sine squared x plus 1 equals sine of x. We now use our quadratic approach, our factoring approach. So we're going to want to factor. We're going to move everything to one side. Well, first, let's combine these like terms here. We get 2 sine squared x minus sine of x minus 1 equals 0. If it helps, you can rewrite this off to the side as 2x squared minus x minus 1 equals 0. Treat your sine of x's just like any variable. If we were to factor this out, we get 2x and x. We get 1 and 1. It's going to be a -1 and a +1. That means over here we get 2 sine of x plus 1 times sine of x minus 1 equals 0. Now we solve each factor. We have 2 sine of x plus 1 equals 0 and sine of x minus 1 equals 0. We get 2 sine of x equals -1. That means sine of x equals -1/2. Over here we get sine of x equals 1. Going to our unit circle. For sine of x equals -1/2. That occurs at, let's see, here and here. So 7π6 and 11π6. So our possible solutions here are 7π6 and 11π6. But we have to remember to add 2 pi times n. Where n is an integer. Now for sine of x equals 1. Go again to our unit circle. This happens up top where we have pi over 2. So x equals pi over 2 plus 2 pi times n. And there are your three solutions. 7π6, 11π6, and pi over 2, all of those plus 2 pi times n.